current API. So what this allows, what this allows now the different teams, so they're able to test their applications with something that is live and what's expected to be maybe in staging and even as you go live. So make the query as it will be intended to be bed and get the same kind of data structure that is going to be implemented in the backend. That's a mock response. So once you have that set up, the different teams continue working with how they're working. Then once this is done, so the backend team has completed working on the API and it's now time to set it up. So they're able to set this up as either a revision, test it, or create a different version to it. So in this case, we'll come, so add a revision. So maybe V1, because that's the actual that's been completed. And then now make that current. So instead of now the request going to the mock response, it will go now to the actual current API instead. So once that has been updated as well. So I'll just show how this is done. So adding the policy it's not hard. So you also get this by default. So let me see if I'm able to expand this. Okay, not. Yeah. So you get all these different kind of policies provided. So just allow me to talk about policies first before we now proceed with the different implementations. Yeah. So policies are used to impact the behavior of your APIs and how that changes how the request will be processed once it hits your gateway. So the scenario, a request is being made, so it will hit first your API gateway. Remember when we talked about that? So it first hits your API gateway, so it's an inbound request. So that's at a global level. Checks for their course that I need to check if there are any log policies that has been implemented. Then goes to the product level. So this request, so a developer subscribed to a product from the developer portal. So what policies are in that product? So is there any rate limiting, quarter limit implemented? What kind of authentication should be done at that layer and all that? So once it hits the product, it's been processed. It now goes to the actual API now. So at the API, you also implement policies at the API level. So in this case, we are seeing JWTs, that's authentication. So you can have JWT, Auth2, OpenID for that. Different kind of policies can be implemented at the API level. So once that has also been processed, you now have also others at the operation level. So cache, rewrite a URL, rewrite the body, check if the request being made is valid, if the kind of response again being returned is also valid. So you can implement policies at any of these levels. So there are policies for at global level, there are policies for at the product level, there are policies you implement at the API level, and also policies at the operational level. So for the operation, it makes sense to implement caching for get. It doesn't make sense to implement caching for, say, maybe delete or post. Till you are able to control that effect, those different kind of implementation. So response, if a response is coming through, you want to mask some certain type of data, you're able to change that using policies. So you're not impacting the code base, you're doing that at the APIM level. Then now at the API level, so authentication. So you have service A calling service B. So a developer calls service A, the service A will call service B will call service C. So service A will be validated using API. So maybe check that the developer credentials are okay, maybe using auth2. But now service B being called from service A, it expects a JOT. So it needs to verify that the JWT being used is valid. So you implement a validate JWT at that service B layer. Also same for service C. So that's the kind of policies you can use, able to implement at the API level. Then for the product level, like I mentioned, you have products for maybe people who are just testing out your APIs, not necessarily clients. You haven't done KYC or approval for them. So you create a product where they're able to experiment, see if it's a good fit for their use case before they can implement it. So create a product for people who are just testing, have rate limiting, have caching that is in place daily. Then for clients who are actually approved, you can now maybe minimize the control behavior. So less rate limiting or none at all. The high usage quotas and all that. Then at the global level, so policies for costs. So it's not only you have your front end and mobile hosted in a different domain host than where your APM is actually running. So configure those costs to allow those kind of requests. Also set up how do you want to do logging. So you're not necessarily maybe using Azure Monitor or application insights. Maybe you want to stream your monitoring or logs, something else. So you're able to implement that also at the global level as well. So there's a level that's missing here called workspace. So that's because workspace is surely implemented with the premium SKU for API management. So in the example I was mentioning, so you have different developer departments working on different kind of products for your APIs. So a risk, a loan, customer onboarding. So different, you want to separate these teams. So you create different workspaces for them. So there are also policies you're able to implement at the workspace level. Again, how this also works is, so at the operational level, you have different policies for these different levels. So as the request comes in, so the check goes through, but how now do you make sure that the policies at the global level are inherited for a certain API? Yeah. So you have the concept of base. So what base does, it's check the preceding levels for your, so in this case, so this is an operation. So this is a get operation. So the get operation will check what kind of policies have been set for this actual API. So all operations in this case. So this portfolio API. So for all operations, do I have any policies? We check. So there are none at the all. Then it goes a step ahead higher. So from now the API, we go to the product. So we'll just see what product this has been set to use. Mobile. So it checks at the product level, do I have any policies configured also as well? So if this point in case is where now you're doing rate limiting for certain product, so it comes and check is there policies implemented at this layer as well. Yeah. So it's none. So again, goes a step higher now to the global level. Yeah. So global level is now all APIs in this case. So do I have any policies implemented again at this layer? So you can see we have now the course implemented at the global level. So by default, when you are now publishing your developer portal, you get to enable course. So that course will be implemented at the global level. So this to allow requests coming from the developer portal are able to access your API. Then checks what methods are allowed and all that. So this now course again checks if there's any other policy implemented. So you get the flow. So at each level, it checks if there's an existing policy, implements that, and goes ahead, goes a step down. So if there are two conflicting policies, maybe they were not set up properly, the one at the bottom layer is what will be used the most. So let me think of a use case. Yeah. So maybe you're using okay, that's not conflicting. Certificates and okay. Yeah. Yeah. Maybe you have auth2 for all APIs. So you're able to override that maybe for a certain kind, for all APIs, you have auth2, but for a certain kind of API, you want to use a different identity provider. So you're able to configure that such that the API, so in this case, I have big conference and Azure. So we'll say Azure Foundry can use Azure Active Directory for under registration for auth2. And then now maybe big conference API, users are subscribing to that, are registering to that using maybe Google. So you use the Google identity provider Gmail for your auth2 validation. So the bottom layer gets simply is what's given priority above the rest as well. Yeah. So we're talking about mock response. So the second kind of response we'll talk about is now caching. So you publish your APIs, they're in use, traffic is increasing. Based from your monitoring, you notice we need to, or the recommendation is I want to implement caching, at least to improve the performance and latency for that request. So like I mentioned, this is an example of a policy now being implemented at an operation level. So what that means is developers, are we able to do caching for a delete operation? Post. But you get the concept. So you come and implement caching for a GET request. So we'll just look at how that looks like. Again, during inbound. So okay, when you're setting up policies, so there are you also have three of these. So incoming, which is inbound. So as the request comes and hits your API gateway, that's an inbound request. So it checks for the policies that are in inbound. Once those are validated, before it's now actually sent to your backend, if you're actually using a backend, so where your API is actually being hosted, it also checks now for policies being implemented, being set up for backend. Yeah. So case use for this, so let me see for all operations. Before now I just talk about, yeah. So you get the set backend service ID that then points to, so get these are inbound. So it points to where, so it tells the request, instead of you having to actually hit my backend, you send this response to this backend ID instead. So we'll just go back to caching and see what the behavior. So we'll just do a test to see how that looks like with caching and without caching, and how are you able to validate that it's actually hitting a cache. Just do that same. That was the first request. Okay. So we do a trace. Come to trace. And see outbound. So outbound is response. It's a response. So you see the response is being sent out to the caller in full. It's actually going to our backend for that request. So the moment we change this now to use caching, yeah. So like I said, for those who have not worked with code, it will look like something complex, but like I said, I'm promising you it's not. So you already have these kinds of policies already pre-set up for you by Azure. So basically, what policy are you trying to implement to set that up? If the functionality is not available on Azure, you're able to set custom policies as well. So now that's where now actual code gets involved. write up your own policy expressions. So we're looking at caching. So it's caching policy. So we do get. So we have to see where are we implementing this. So caching should be done in inbound. So when a request comes in, we want to check if the value is already in cache. If it's in cache, use what's in cache. If not, hit the backend. Then store what has been collected now to our cache so that the next time you're not actually calling the request. So for inbound, we say get from cache. Where you have, okay. So lookup vary by developer. So there are some requests, maybe if a call is being made, you want that to alternate based on who is calling. So you're able to change that from here. So vary by developer groups as well. In this case, that's not valid. So you just change this to false. So this false. Vary by header. No. Let's look at. Okay. Let's do an easier way. Set this up. Yeah. So this is what I wanted to show. So this is a much easier way of setting up policy. So cache lookup or store. Yeah. Like you can see in this case, you're only setting the duration for how that cache should remain. Alternatively, you're able now to change these different aspects. So if the request should change based on who is calling that, you set this to yes. That's what you're seeing. I was changing to false and true. And all these. Yeah. So from this point now, once you check this, you'll see that we have now two. So one being set at the inbound level. So when a request comes, check if it's in cache. If not, go and fetch the response. Then now store that in cache. Next call being made. Just save this and then make a call as well. So right now, if you send a trace, so the first one shouldn't necessarily hit cache. Yeah. So you see, we are now it's set at the backend level. But now the moment we send a second request, even a third request, see this now being fetched from internal cache. So cache lookup resulted in a hit. So it's now using cache to get that response instead of now going to the backend. So what this does, you're improving latency, you're improving response times for that kind of PI. So that's a second policy that's also normally used. Then now we'll talk about transformation policies. So what I mean by transformation policies, these are policies that now alter how your request looks like. So whether it's inbound, you want to modify maybe the query being made by a customer to match what's being expected, or it's outbound. So you get a response, you want to strip off some kind of data, maybe personal PII, some personal identifiable information, or even hide your backend URLs. So you want to change all those. So those are examples of transformational policies. So we'll just look an example of that. That's first. Yeah. So again, back to our design tab. Like I mentioned, we're going to spend most of the time on this view. Yeah, go back to our add policies. Let me show all of them instead so that we're able to see how they're categorized. Yeah. So transformation policies. So from a response, you want to change maybe a value to a different value based on maybe a product or who is calling it. So find and replace that value from our body. Then we'll also be looking at this, converting JSON to XML. So you have modern APIs being called by a legacy system that expect an XML response. So call that your API returns a JSON. So instead of now having your developers go back and do double work to set up XML, set that policy, have that response transformed to an XML, continue the work. Then mask URLs in content. So you want to hide your actual backend. You're able to mask that, rewrite a URL, same concept. So set backend service. So case scenario, a request comes, it hits the first backend, too many requests. You're able to do circuit breaking and set a different backend service for that to be called as well. Then set body, set HTTP, set request, restring, status, convert XML to JSON. So legacy API, and convert it to a JSON request as well, that then transform XML to Excel. So these are all transformation policies you're able to utilize. And again, like I mentioned, they are not limited. You're able to customize these based on the policy you're trying to use and the behavior you want to implement for your case scenario. So I'll just show an example of what the transformation policy we have. So we're going to show conditional logic as well. So if else, help me out, devs. So it's usually if else and then the third one. Look into that. So we're using get, sorry. Okay. Let me verify this. So yeah. So I'll just use a different API for this so that we don't change. Okay. Yeah. So we're going to use this API for that. So it's basically a GET request. So it's a big conference. So what we want to do is do a condition. So if the person calling this API is using, okay, the ideal behavior if this is, or we have a developer team that works with XML for purely. So what we'll do is check if the product being used is that product. So in our case, it will be mobile. What we do, convert the JSON response to an XML, then return that kind of response to the client. If not, sorry about that. So we're taking care of our virtual audience. So yeah. So like for the case scenario I was mentioning, so we want to check if this condition happens, return this kind of response, otherwise return the default. So we'll just test to see what's the default response, this API. So we're expecting a JSON response, this JSON application. Okay. So it's a JSON response by default. Now we want to do this for all our APIs. So go to all operations, then I will say policies. We'll do that. So before you go ahead and implement the policy, who can tell them where we are implementing that condition? So the use case is we want a request comes in, then based on the caller, on what product is calling the response, we return an XML instead of JSON. So at what point are we implementing the policy? So will we check that when it's coming in, or we'll convert that while the response is now being returned to our client? Anyway. Okay. So just help you out. So we'll make that conversion while the response is going out. So because we can change that at the inbound, but that policy will not be respected while the response is being returned now to our client. So we do that now outbound level. Yeah. So it's choose when, basically it's an if-else statement. If this condition evaluates to true, do this. So you can have a couple of when. So we can have another when at this. When that, if the first condition is not true, evaluates the second one if it's not true. So first condition, first when, second when, third when. So they can be any n number of times. If any of those when condition is not true, by default, evaluate what's in the otherwise condition. So basically an if-else statement. That, yeah. So we'll just, yeah. So the condition here, what the condition does is, so it will check for this API, for the caller who is calling this, which product are they subscribed to? Okay. If the product is the name of the product is mobile, basically do a conversion from JSON to XML. Always do an apply. So we're also going to see how do you now use what's implemented in the request header. So we usually have content type. So if the content type is application/JSON, you want to ignore that. You can ignore that as well and return a JSON, continue using that as well. So we'll just save this. Yeah. Then validate our changes. Still. Stop. So there's still JSON, just a moment. Let me. Oh yeah, I think it's okay. Yeah. So you see, we are not implementing any product at this point, so we're using none. So when you send this request, okay. So I'm getting an internal server error. I think that's our backend. Not sure what's impacting that. Let me try another operation. We should be able to see that in effect. Oh. So I'm not sure if my screen's big enough for that. But you see now the response returned is now an XML once you set the product to mobile. So I'm not sure what's happening once you remove the product type. So this should still be able to go through and return a JSON. Should be able to evaluate that. So you're also able to see how that's being evaluated as well. So just send a test to check that. Second. And see at what point is that being evaluated. So see, it checks if the product name is mobile, the value is true. It now implements that policy JSON to XML, then implements that. So like I mentioned, Azure provides different versions, different kinds of policies. So, and you're not limited only to what it provides. You're able to customize this and do a custom. You're able to do custom policy expressions, which you can use for your implementations. So we're still going to see a lot of use cases for policies. For how do you utilize policy expression even in your security? So you want to validate maybe a JWT. You want to hide sensitive organization data. Like in this case, if you're careful, you'll notice we were exposing our backend URL where this URL was actually being called for. So how are you able to hide that kind from your response as well? So I think I've been on a rant for a while. Who has any question on policies before we move ahead? Yes.
The policy, is it like a DSL for the phone?
Yeah. Hi.
So, because I'm lazy and I want to learn a new way of writing policies, is there another API for managing this, like a CLI?
So,
because I've noticed the policies, they're kind of tasked to write.
So are you able to implement this from the CLI? That's what you're trying to implement.
Or another
language.
Yeah, or an SDK.
So for policies, yes, you're able to do that with SDK or the CLI, but still when structuring the policy, you'll have to put it. So policies are basically C# snippets. So it's still C#.
So even the SDK is in C#.
Yeah, even the SDK.
Okay.
Yeah. So if you're using SDK, you'll set up the API with SDK, onboard your APIs. But now when you're defining now policies for an API, you'll still write the C# snippet for that policy, and then now point it either as a file or put it string, how you're doing it. Yeah.
And will you cover information on how this is built later?
How
are they built by request or log
policies
for the
API or the billing?
Or that will come later.
So okay. So we didn't touch on billing, but I think I can quickly touch on it because it wasn't part of this. But yeah. Yeah. So this is now the pricing tier for APIM. So it's still APIM is still very, how do I put it? So it's still a new product. Azure are still experimenting on their pricing. That's why you'll find its pricing quite heavy or expensive because it's intended for enterprise users mostly, if I'll put it. So there are two versions to APIM. So there's the classic and then now there's the V2. So the V2 is more improved in terms of performance, latency for the gateway. Then now the classic is the actual version. But now what does classic has more features? Okay. Not necessarily a lot, but it has more features. Some features are available in classic, not entirely available on V2, because V2 is now where Azure is now looking to move into. So for starting out, the developer tier is quite friendly, and also it allows for all the features, I think, except SLA, because it's a developer. So it doesn't give you an SLA, but you're able to experiment with all the features. Again, no multi-region deployment. So it only supports a single region for that. But you see, you're able to get all the features for the developer. When now you're deciding now to move into a production use case or even staging. So you have vast options for that. SLA, the SLA cuts across for anything that's not developer. So you get SLA by that. Then now the different features now are supported based on what tier you're using. So multiple custom domain name you get, that's restricted. But again, so when now you move now to premium, you're able to now get all the features in classic. Like I mentioned, V2 is still quite new, doesn't have all the features even in premium, like self-hosted gateway, which I find is being considered the most. So that's not available in premium, but just gives you a good SLA, gives you good throughput, and all the other aspects to it. That's in terms of pricing. Yeah. Yeah.
Sorry, the reason I was asking about the pricing is because I know Cloudflare, they have a similar product. And if I go to my boss with this, that's probably the first thing he'll ask me, have you checked the competitors? I wanted to know if you can do the self-hosting, because I think that's a big deal with GDPR for us.
You're able to do self-hosting, but now it restricts which tier or SKU you're going to use. So if that's a major pain point, so basically you're limited to premium classic. Like I said, so Azure is still experimenting with the product, so it's your choosing. Yeah. Any other question from the house? Oh, we move to our next. Yes. So for second part, we're going to talk about security. So I think we started off the first talk Bernice shared was on security. So I think the biggest concern usually for organization, it's usually security level. So these days usually there was a concept that came shift left security. These days it's start left. So whenever you're starting out, so from the infrastructure level to even how you're doing your development for APIs, so security comes as a first concern. So before I just move on to what we have today, so I'm just going to share an architecture we usually use for clients when setting this up. Yeah. So when talk of security, you'll talk of security in defense layer. So you'll have one at the infrastructure, then now come into how you're onboarding your APIs, access and control, then authorization and authentication. So in this use case, so this This is a common use case you'll find being used while setting up APIM. So you have workloads. So you're doing hybrid. So some workloads running on-prem, others running on Azure. Then now you want to do a central management for all these APIs with APIM. Then set up authentication and authorization. So either using Azure AD for single sign-on or any other identity provider for that. Then you have also third-party APIs. So how do you bring all these now together and still factor in without compromising security? So for the infrastructure part, so just touch a bit on it. So you have your APIM running within a VNet, so an internal VNet. So what that means, it's air gapped, not completely inaccessible from outside the Azure environment or from within your VNet, only accessible within your VNet and by the administrator. Then now your VNet now extends to your on-prem. So either using IPsec or express route. So whichever option you're going with. So workloads running on-prem are still able to communicate with Azure. If that's not an option, the self-hosted gateway you're talking about. So run host your own gateway on-prem and still get the capabilities of Azure APIM. Then now you've set up all these. So how do you now allow access now to APIM? So add networking layer which will route to your APIM. So in this case, it's an application gateway with WAF. So you can still use Azure Front Door for that as well. Do away with the application gateway WAF and implement an Azure Front Door. So that does two things. So it does one for the networking bit where receives requests, forwards it to your gateway. Then now it also does the security aspect to it. So OWASP mitigation, DDoS mitigation. So you'll get all of that. Then now, so outside infrastructure, you now come to how now your clients are now able to interact with your API, your developer portal in that case. So single sign-on, Auth2 for authentication, make a request, get a token. That token is validated by your gateway at the PM level, and then now the request goes through. So that's a brief on security at the infrastructure layer. So that will not be a mere concept of what we are talking about, but you can read more of this. I know we hate reading documentation, but trust me, try it once in a while. It's good. So how do you mitigate OWASP? How do you mitigate DDoS? Get to understand how those different effects apply on your APIM and for that. Then now, I think I can shut this out. We are done with the developer portal. Yeah. So for security, we are going to talk. So yeah. So usually most people take care of this. So you've air gapped your APIM, you've done single sign-on and Auth2. So that's valid, that's secure. You have policies that are being validating the JOT and validating AD tokens. But there's usually a concept we usually miss out. How do you secure communication between now APIM and where your backend resides? So if you're doing mutual TLS, or are you still using basic username and password to authenticate requests coming from APIM to make sure that any request that's hitting your backend traffic is authenticated or is confirmed to be what's coming from APIM. So you take care of this, but we ignore that part. So we'll also be looking at how do you take care of validating and what are the supported ways you're able to do that aspect to it. So again, like I mentioned, so for APIs, APIM, so like the default, you get subscription keys by default implemented by Azure. But like I'll say, subscription keys are not enough. So easy to leak. Maybe a developer committed it to GitHub. Those things happen. So it's not by default secure on its own. So how do you take care of adding another layer of security besides the subscription keys? So like I mentioned, so the developer portal is where your developers will do most of the work. So while they're being onboarded, this is where you're able to set up what kind of authentication and authorization will be used for them to communicate with your APIs. So you can add an identity. So in this case, it's username and password. You're able to do this, but as you can see, Azure is becoming, so they are deprecating all the other aspects. So this taking care of signing up. So you're basically you're delegating signing up to a different provider. But then how now do you take care of tokens being before a request hits your backend? How do you validate those kinds of tokens in terms of identity provider? So you're able to do Auth2 and OpenID for that. So it's just what we're showing in this diagram. So a customer is signed up to the developer. So if you're using Azure AD, so Azure AD is quite straightforward because it's Azure supported. You can replace that with any other third-party identity provider. So Google, GitHub, whichever use case. So once a developer is signed into your developer portal, so the developer portal is configured with your Auth2. So calls being made from the developer portal. The developer portal will now act as a client to your identity provider. So go and fetch the token, verify you're a valid user, and then now use that request to your APIs. So that's now on the Auth2 and OpenID Connect. So again, but once you're setting that up, it doesn't necessarily mean now it's implemented to your APIs. So you still have to configure your APIs to now check for that, validate that a user who is sending requests to the token. How do you validate that that token is valid? So again, we are back now to policies. And I think that's one of the reasons we started out with policies. So you're able to understand where this is being implemented at. So in our use case, if you're only using a single Auth2 provider or OpenID provider, you can implement this for all of your APIs. So at the global level. So for any inbound request that comes in, you're able to add that kind of authentication. So this is with basic bearer tokens. You also have the option of with client certificates. So we'll be looking at this when we're now looking at how do you secure APIM now to your backend. Then now you have the validate. Yeah. Sure. Yeah. So validate Azure AD token. So if your auth provider is Active Directory, so validate Azure ID token, it sets up the client URLs and secret. So you set up that in Azure, and you only basically pass the client ID or the application ID. If you're using something else other than Azure, yeah. So if you're using something else other than Azure, so it defaults now to validate JOT. So you're able now to provide your OpenID config URL, then the issue signing key as well for that. So if you're using Google for those third party, so you set that up in your identity and your Auth2 and OpenID, then you basically just pass the config URL and the signing keys in this case. Like I mentioned, so validate jot doesn't necessarily have to be with open IDs. So you can set even this up with if, how do I put it? So your APIs also generate their own JWT tokens. So you're still able to validate that and make sure that they are valid for each request that comes through. Yeah. So that's on policy. Okay, that's on validation with the true and OpenID. So that's usually done. But okay, not done. So the other kind of policies we'll touch on for securities now. Like I like to put it, so when your APIs are interconnected, so I think I was talking to one of my colleagues and he said the more we expose our APIs, the more that what kind of data, do you know what kind of data you're exposing without actually exposing? So you've a scenario, okay, let me just cut this. So all these different APIs are talking to each other. So actually sending the data you need. But what kind of data are you also sending that's also not needed for this API? So we'll just take a look. Example. Let's check if we have any policies implemented for this. Yeah, cache doesn't do much damage. Yeah. So for my security people in the house, I want you to help me out on this once we hit this request. So what kind of data do you think shouldn't be in that response? So we'll just give this time. Yeah. So you've published your, okay, this doesn't expose much. So just a moment. I'm not sure. Yeah, the demo codes are up. Sort of impacting our requests. So let's test this. Okay, yeah. I don't know if there's a way to expand this. So anyone in the house, so what vulnerability do you think we are exposing from this response? So it's a normal response. We've published your API. What do you think we're exposing in this kind of response? Anyone?
So from the response headers, the two X powered by ASP.NET, and the other one for the version of the ASP.NET. So it could aid in the recon process for identifying the vulnerabilities that exist on that particular version. So it's always recommended that we
Remove the headers.
remove that from the responses headers.
Thank you. Thank you very much. So that's correct. We still have another one. So he identified two. So we're exposing headers that have exposing information. Any other one about spot? So he spotted the ones in the headers. So based on the rest, okay, from the body. That's a hint. You want to try?
We are exposing the parts of possibly other APIs, and then we also see that there's a name and the value that are then.
So yeah, thanks for that. That's correct. So we also, like you mentioned, we're exposing our actual backend API. So remember, when you're making a request, the intention is that the developer should hit our APIM gateway, not our actual backend API. So once we are exposing this, if someone is really investing in taking you out, you've given them where you're actually hosting your APIs. So this kind of, you're actually exposing your backend where your backend is hosted. So they're able now to make requests to this backend where you've not. So case in point, you've only done the policies, you're doing authentication, authorization, subscription, and all those fancy good stuff at the APIM level in terms of sec. But now, once you give this backend API, it's not rate limiting implemented. It's not authentication and authorization protected. And all that, it's not DDoS protected. So you are doing all those fancy and good stuff with the APIM level. But now, once you give out this, they're now able to use this directly without having to go through your gateway. So imagine you have now to take care of removing all of this for your 50 APIs or 100 APIs. Well, developers can take care of removing the response headers in the source code. But how now do you get to hide this kind of data? So again, we'll go policies are a solution. So remember I mentioned policies are why impact the request and responses we are getting for our APIs. So for this case scenarios, we'll just do it at the API layer. So just call it that word policy. So our content type was a XPNet version. So we really don't care about the value. We just don't want it to exist. You know, we don't want it in the response. So you go ahead to remove that as well. Then the other one was expowered by. So again, we don't really care about the value. We just don't want it in the response. So all that. Again, actually, this for inbound. So this, hey guys, I'm setting this in the wrong part and you're seeing you go ahead. Okay. So basically what you're doing is for any header, for headers for SPNet version and powered by, remove those headers. Then for any URL, redirect that now to point to our actual APIM URL. So instead of actually getting the backend URL, it now points to our APIM URL, the same one that users are now making requests to. So I'll just go to verify this. Yeah. So no more headers. Take note. So now our URLs are actually using our API gateway URL instead the actual backend URLs. So these are now data returned on the response. This is now the actual data. So these are being used. So for this speaker, this is the reference session. So we are not modifying that. But again, the other one, they're using the APIM URL for that. So that's one of where we're implementing policies for that. For security. Then the second aspect of security we'll also talk about. So okay. We'll skip managed identity. So we'll talk about integration with other third-party APIs. How do you manage credentials as well for that? Yeah. So yeah. So remember the story I was talking about when we started. So Contoso Bank, the idea is to onboard our users from mobile. So how do we verify the identification? So credentials, national ID, if they're using passport. So the government is good. They've given us gov.ke TRA API and developer portal. Nice. We want to use those kinds of APIs. So our APIs are communicating with that. How now do we set up credential management? So when an API from my backend calls that third-party API, how do I pass my credentials? We don't want to use authorization. Okay, not authorization token. We don't want to use username and password. You don't want to pass your username and password through the requests. Secondly, we are one organization. We don't necessarily have to create different authentication apps to get the authorization code. So set up one, use those client secrets and client credentials to send our requests. How do we do that? So APIM makes that quite easy. So we have the concept of credential manager. So just bear with me. For this, we are using, for this I'm using GitHub. So I want to call the GitHub API. How do I pass on my credentials to that and test? So not necessarily. Okay. Yeah. So GitHub has different ways where you authenticate. So this can be any authentication provider or for your API. How do you authenticate? So if it's using personal access tokens, auth apps. So in this case, we're using an auth app. So you create an auth app, then now you register that with your APIM. So basically, yeah. So the identity provider, what's the name? So there's a connection name, and then where does that redirect to? Yeah. So basically, these are the settings. So give your client ID, give your client secret. What's the grant type? So authorization code, access tokens. Then what are the scopes? So for that API, what are the scopes this application registering is able to access and save? So this can be done even for generic, so doesn't necessarily have to be with the registered identity providers. Let's look how to create one. Yeah. Again. So Azure has added the most likely ones you're likely to use. So Google, GitHub, LinkedIn, Auth2. So for any API that's using that provides Auth2, so Kicklock is not here, but you're still able to set that up using the generic Auth2, then the authorization code, or if it's client credentials, set up the authorization URL, client ID, client secret, refresh URL. Again, what's the scopes, then you create. So for APIs, now when you are now setting up the APIs, so the identity provider had this for GitHub as an example. So for this, for all operation, I think, yeah. So for requests in this API, what it does, for any request that comes, it will get the authorization context from that provider, and then pass in the header name authorization with the bearer and that value. So you don't have to take care of how you're getting the access, the authorization or access token in this case. Then now the header name, user agent, and API management, this required by API management. Then that's it. So while you test this, so when I'm making this request, or when there's any request in this API is called, so again, it's still exposing a lot of data. But you see that you get the concept. So you're not passing any kind of headers with your actual, you don't have to take care of getting the bearer token or access token. So APIM gets that for you. So APIM now communicates with the identity provider, gets that, and then makes that request to your third-party provider for that. So that's on credential manager. Then now, lastly, we'll talk about managed identities. So your API is using, so it's fetching, it require, your APIs require maybe some secret data stored in key vaults. So in this case, Azure Key Vault, or it needs to communicate with any other Azure resource. So you're able to achieve that now using managed identity. So either system assigned or user assigned. And then now you're able to grant, again, the concept of role-based access. So what is this? What can this identity be able to access from Azure? So in this case, you see it only has permissions for services for OpenAI. We'll be using OpenAI for that. Then it's able now to fetch secrets and certificate from Key Vault. So you don't necessarily have to hard code credentials or pass those kinds of sensitive data in your APIs. You can store those in Key Vault, where you are now, it can able to do it's able to do rotation for you without you having now to change back those kinds of data in your API each time those changed. Also, a much secure way to communicate with other third-party services. In this case, it's cognitive services OpenAI. So we'll be looking into that when you now touch base on what are the supported GenAI workloads we're able to implement with APIM. Then now certificates. So like I mentioned, we usually take care of securing this side. Take care of doing the security until at the APIM level. But how now do we secure our communication from APIM to on-prem services? How do we secure those kind of requests? So APIM supports three types of way you're able to, actually it's two, not three, because the other one is none. example. Yeah. Yeah. How are you able to secure your backend APIs communication from your APIM to your backend? Like I mentioned, so it's not necessarily that every user that goes through your APIM is a valid user or has good intentions. So other people are patient. They'll go through all that process as long as now they're able to actually hit your backend APIs. How are you able to validate that? So there are 3 ways you're able to validate the credentials from the APIM gateway now to your backend. Not 3. So none is not a way. So you have basic. So if your API requires a username and password, so basically pass a username, password. It will be sent along for every of these requests to this API. Then now this the recommended way using client certificates. So basically create certificates if they are CA provided by CA that validate your backend. Use those. If it's self-signed as well, you're still able to do that. Onboard it to APIM, then basically pass that to hit your request. So I'm not able to set this up because I'm not hosting this backend. So I'm not, this Azure websites.net is not my backend. But the idea is every request that now hits my backend will pass this certificate as well. My backend is now able to validate this certificate thumbprint if it's being provided from a CA certificate authority. In that case, it validates as well that with the issuer. If it's expired, I'm able to validate that and make the request as well. So sorry. Onboarding certificates to APIM is quite easy. It's quite easy. Sorry. So basically, yeah. So give it a name. So any default name, maybe the customer name for that, and then pick it from if it's being hosted on Key Vault. If you're storing the certificate in Key Vault, basically select it, pick it up from Key Vault, much secure way. Yeah. So this is how I embodied the one that we were able to see previously, the PM service. Also, if the customer gave you a file and a password as well, you're able to upload that. Yeah. So if you're onboarding a client, he gives you a client certificate, you're still able to upload that as well and use that operation. So making sure that the traffic that's coming from your APIM now to your backend services, it's also encrypted and secured and also validated in your backend. So any question before we move ahead? Yes.
Okay. That part for certificate after you uploaded, does APIM has like a capability whereby I can expose like an endpoint to that certificate? So, for example, for Android or iOS, there's that capability whereby you do certificate pinning, and majorly it depends. You have a service running on the backend that fetches that certificate either from the key vault, then exposes either the public key. So instead of going through that entire process, I think it's something, I don't know if the APIM has that capability whereby the way I've uploaded that certificate, I can expose an endpoint where I can get the certificate that is only the public key and maybe the expiry date.
If API is able to set your public, so public certificate expiry date without you necessarily having to onboard it as a certificate.
Need to expose an endpoint to this certificate whereby I can share that URL to someone else to fetch my certificate.
Azure doesn't provide that capability, but I think how you can do it. So if you already have the endpoint, yes, you can onboard that as an API to APIM, but it doesn't provide you like that direct capability where it now creates that endpoint for you to fetch this certificate. No. Yeah. Yeah.
My question is similar to his. However, mine is if we store the client certificates in the key vault for a PIM to validate the backend, how does the rotation process work? Okay. How does the rotation process work? Does a PIM automatically pick up new versions from the KV, or do we have to redeploy or upgrade? Since we are dealing with certificates and security-wise, certificate rotation is the test.
Yeah, so that's the benefit of now. That's why when I was illustrating, I was saying I prefer using the key vault method rather than the custom method. So, because the auto rotation happens at the key vault. So, no, you don't have to redeploy because for every request that's being sent. So when you're implementing the policy, APIM implements that request with that policy. So if that policy for every request it sends, it validates that certificate. So it checks. So if it's in key vault, you're doing auto rotation. So it automatically check if you only. So there are three ways you can validate a cert. So you can validate an issue, an expiry, or the thumbprint certificate's thumbprint. So if you're validating the thumbprint, APIM uses a policy to check that that thumbprint is valid. If it's not, it returns that invalid client certificate. So if you're actually doing it in Key Vault, the auto rotation works on Key Vault. So any request being sent, it's only being validated to Key Vault. So yeah, nice question. Thank you. So anyhow. Okay. Sorry. Yeah. So for our third component now, we're going to look at monitoring. Yeah, so monitoring and analytics. So basically, it's now time to publish, to expose your developer. Okay, you've done the onboarding, your APIs are now live, they're being used. But you need a way to know how are my APIs being used? What kind of API is getting the most hits? How am I able to trace a failure from one request to another? In observability, we usually talk of the three signals. So how am I able to get metrics, logs, and traces? How am I able to follow a trace from a point of until the request failed? Yeah. So APIM, it provides analytics by default for you. So when you're setting up APIM, you configure an Azure monitor, just as what we were showing during the presentation. So your Azure monitor works as the workspace where the logs are being collected. And then now analytics will use Azure monitor as a query to query this kind of data. So this what by default you get a timeline, geography. So timeline is basically how are requests being used based on time. So how many operations are, what are the records for 404, how many they were, at what time, 200, and all that. So data transfers well. So this timeline is the behavior of the requests and all those data on time. Then geography. So where my request being called highest. So this based now on the gateway as well. Then APIs. So which API is being hit the most? You're able now to narrow it down to which operation for an API is being called the most as well. Then which product is also being utilized again. So case scenario, we had in our case we were talking of two products, one for members who are just experimenting and one for actual users. So if you want to know how, if actually people are experimenting a lot with your product, so you're able to come and see that the product, maybe it's a guest product. So guest product is actually having more requests than internal product for internal devs team. So it informs you people are actually interacting with the APIs. Then you're even able to narrow that down to subscription at the subscription level. So a client who is using an API has been DDoSed. You're able to get that data at this point. So the ripple effect is being transmitted to your API. So you're able to see a certain subscription is having a lot of requests. Then you can get that with the time request. It informs you it's now time to go and invalidate that subscription key, control that you can access. Then now, again, data for users, requests, and language models if you're onboarding a PM, then AI workloads for that. So total tokens completion and all that. So the analytics view gives you a high level overview of the interaction for with your API. So request. So it's basically a summary. So when you want to actually dig much deeper, we usually talk of application insights. So if you've used Azure before, usually you've used application insights in any other product. So it's also integrated with APIM to give you the benefits that you get with application insights. So if application insights, basically it's an observability backend for those who have not used it. So it allows collection of basically metrics, traces, logs. You're able to visualize, query, and monitor all that. Yeah. So like I mentioned, so analytics gives you an overview, a high overview of how your API is interacting. But when you actually want to do critical observability, so application insights is now where you're able to achieve that. So there you get some custom, you get default dashboards. From that, so fail requests, server response times, server request availability. But again, you're still able now to do the actual investigation for how your APIs work. So in this case, just send. So live metrics, so we'll just give this time to load. So live metrics is actually this. So this now real-time performance of our API and requests being made. So SPO, servers, requests. I make a query now. Okay, let me open this. So let me make some sample query at least to get data on that. So we're basically just simulating traffic that we're able to see that right. See, it's actually real time. So any activity you get, it's directly integrated within your application insights. So you're able to get those metrics, real-time metrics for your APIs. And then, so that was on metrics. Then transaction patch now deals with traces. So how are you able to trace like a failure or a request from one endpoint to another? So you're able to get tracing as well within application insights. They're very good, also gives you summary for that. So a request being made to API github.com, how did that behave? Then, so this is a failure. You're able to see this request failed at what point as well. Then, so availability. So availability to how available is your gateway. In this case, it's gateway, but you're able to set up custom tests to your actual endpoints. So your backend endpoints and get to see how available they are. So what classic tests or standard tests do? So they hit your backend, they make calls to your backend to test if they're up. So you're also able to get those results as well from this point. Then failures, I think this is the most used. So it informs you on which requests are failing and at what point. So you're able also to trace failing requests to any custom point. So in this case, the conference API failed for 4 times out of 6. So you know that it's time to act to this API and try to solve that. Then you're still able to see which part is failing. So is it failing at the APIM level, or is it actually failing at the gateway level? So in this case, it's the expression evaluation is the one that's failing. So this is a gateway APIM problem. So not actually a backend problem. Yeah. Then now performance. So how is your APIM gateway being impacted as well? Then for requests, you're also able to get those kinds of success requests for that. Then we'll now talk of monitoring. So, logs. Yeah. So you're able to query logs as well. So it's what's being provided by the dashboards, but you can customize this. So you say it's custom query language. So you're able to query different kind of behavior from your logs and get that data, designing it based on the query language, the custom query language for this. Yeah. So that's how overview of how you're able to do application insights and monitoring as well for your API. So is there any question on monitoring before we move now to onboarding our models for AI and Gen AI workloads? So every company is
On one of part of the matrix, I think I saw CPU being mentioned. Is it there?
just give time.
So my question is, given that you can see the metrics for the CPU, and I believe now the translation to that would mean when as an organization you subscribe to this service and you have APIs running, behind the scenes you are assigned a dedicated instance hardware, or is it a shared instance? What does that CPU speak about on that aspect?
So the CPU in this case is for your gateway. So it's not necessarily where your APIs are running from. No. So the CPU health total, and this for your gateway. So it's actually CPU health for your gateway. So this what now informs the performance of your gateway. So if I need to scale the instance, so by default, you usually start with 1 instance unit of a gateway for an APIM. So this CPU these are metrics for your gateway, not your APIs, not for APIs. So requests being made, remember requests first hit your gateway before now they go to your backend. So your gateway is the central point. So these are what this CPU is related to, that, not necessarily your APIs or your backends. Yeah. So it's what now will inform you that it's time to add another instance unit to my APIM. So if you're doing multi-region deployment, in that case, it can support. If you need HA for that, so does that, but it's for the gateway, not necessarily your APIs.
Question on the logs. Was not really keen, but maybe you can recap. Do we really have specific logs for maybe like security, like access logs?
Okay, no. So the logs you're getting, these are application logs. So basically done at the gateway level. So requests coming to the gateway and the response. So the response that's being returned, that's the logs you're getting. You can also override your APIs to provide application logs for that, which will also be transmitted now to the Azure monitor. So let me just show this as well. But it's not access logs in terms of security. No.
So to mean you don't have any logs to the visibility of maybe tried access to the APIs, including the backend of the
APIs. No. So how are you able to know who? Like, I think it was a question that was asked during the presentation. Do you care about who's calling, or do you actually just care about how many are being called? So that data with APIM, how are you able to get who is actually calling what kind of API? So you get that data in terms of the subscription keys. So requests, which subscription key is calling which API, and that. Yeah, because that's how you're able to differentiate which request is being made from which client and what. Yeah. So I think I'm just going to rush over the last bit. Masaa za ile hali ingine. So just allow me to finish up on the last workload we had for today. So AI engineers in the house who develop AI workloads, models. Okay, so yeah. Yeah, so this open up. So just a rewind of what were our story before. So we're talking about our customers need a financial assistant who they can quickly hit, hey, what kind of workloads am I able to, okay, what kind of loan am I able to access based on my usage history? So we are now talking of AI into our investment. So our platform in this case is Azure AI Foundry. So for those who are new to Azure, so it's basically a central platform where you're able to access already predefined models. So think OpenAI, GPT, DeepSeek, Anthropic. I'm not sure if Anthropic's there. Yeah. So you're able to access all these different kind of AI of Gen AI models, and then now utilize them for your personal workloads. So fine tune, play around with them, and all that. So in our case, so I don't have one that's fine tuned, but the concept is you can fine tune your own model from this point, and then now utilize that. The developers can call that and utilize that in their APIs. So what's the challenge? So the challenge becomes, so from Azure AI Foundry, not able to expose the key, sorry. So you have different teams. So you have a loan team, you have custom onboarding, you have all these different teams, and you have a single AI team that's working on the models. So the challenge then becomes if I'm supposed to share, if the APIs are supposed to consume this model, then they only use this single key. So I'm sharing a single key to multiple teams. So that's already a security risk because any team can expose that. Then I'm not able to point out, or I'm not able to point out which developer actually exposed that API key for use. Then again, how now do you use this now in your application? So like I said before, so the normal way, we'll have to set up this code in our application and how it's used, set it up. It's repetitive. So if I'm doing 3 or 4 different APIs, I'll have to do the same code, same way. So again, it's cumbersome, tiresome. How then does APIM help to achieve to monitor or do away with this? So previously I mentioned with APIM, so the goal with this is, so let the people working on the models do the model development, and then those working on APIs do what they do best, consume APIs. So APIM now allows you to onboard a model and then consume it as any other API, that case. So you don't necessarily have to come and, so point in case, I'm not familiar with chat completions client or all this, but I know how to consume an API and I want to use that for my workload. So what APIM does, so this gets onboarded. So will not necessarily be onboarding one, already have one onboarded. So give it a name, the base path. So base path is basically the path that's been will be hit, and then either OpenAI as a compatibility or Azure AI, then you're able now to set up managing token consumption. So which team is utilizing what amount of tokens? I'm able to also monitor that kind of thing. That then semantic caching. So for some questions, like if someone, so normal questions, so where are your branches located, what time do they work? So you're able to cache that in semantic caching for your model so that it doesn't necessarily have to consume tokens, but rather just use the cache to get that kind of response, then return the response. So like I mentioned, so I already this and that. So in this case, I already onboarded an Azure Foundry. So I'll just show how this works. So I'll go to completion. I don't necessarily, I think that's the most used. Yeah. So you get a single endpoint. You're able to interact with multiple kind of models. So in this case, so if I go to my models, you see I have like 4 models. So FIFO, mini reasoning, and all that. So with APM through Azure Foundry, so I'm using a single endpoint and I'm able to interact with all those different models. So in this case, this would be FIFO. Change anything for API version, and then content type. So you're actually calling this model like you'd call any API. So the same way you're making queries for the Carlast and Big Conference and GitHub user, it's the same way you're consuming this API for this model. So so you get the idea. So a JSON response. So you're consuming this as you'd consume any API. So this makes it easy for people who are working on the API side of things. So they can call the models as they'd call any API, pass in the required data without having to impact what's being without having to necessarily understand how model SDKs work. Yeah. Then now also, how do you monitor the usage, and then how do you limit the kind of token, the amount of tokens consumed? So you're also able to do this through policies again. So limit the LLM emit token metric. So you're able to monitor this through subscription and product, and then limit the amount of tokens being consumed by a request, and also provide the information of how many tokens have been consumed and all that as well. So this also informs you on the kind of questions and consumption, maybe the kind of question and prompts your clients are making to your models, and what's the average amount of tokens that's being used for those kinds of responses for that. Yeah. So also we talked about one of the challenges about now how this was being consumed was on the API key. So Azure Foundry provides you a single key for this use, but now from APIM, your developers will now use the subscription keys available by APIM, or if you're using Auth2 or OpenID for authentication, or Auth2 to access tokens for that as well, you're able to implement that and get the same flow of how you're doing your normal API consumption. Then lastly, on monitoring, so it also extends how you monitor the usage for your AI workloads. So you're able to see the amount of tokens being consumed. Yeah, so completion and prompt tokens. So, yeah. Let's do unique so that we can able to see the different kinds. Right. So again, the concept of problem. But the idea is you're able to monitor which kind of product or which kind of subscription again is consuming the highest number of tokens for the requests that are incoming. Yeah. So I'm not sure why it's not picking up. Usually takes time to load. But you're able to get that kind of analysis and data as well, even in your monitoring for that. Yeah. If there's any question, I'll take them, then we can break for lunch. Thank you.
Yeah, thank you for the presentation. So I am particularly having a question regarding the Azure Foundry and also on the API on the API management. So we know, like for you, of course, now we're in Azure, but there's that aspect where you'd want to expose it. And then we'll talk about developer portal. So yes, we might be having a developer portal, but there's the old one and then the new one. But then what I'm wondering, like, let's say we want to monetize our APIs and we want to do rate limiting. So is there a way to do rate limiting so that I can know this has hit a certain threshold? And how, again, of course, I know Azure is not like made particularly for the Kenyan market, but how do I integrate M-Pesa? Because I know we might have something like Stripe or whatever, but if I was to monetize my APIs, so how would I leverage the developer portal? And to make sure for every API call, I can do rate limiting. Let's say I have a certain number of calls per day. So whenever I hit that threshold, I'm getting my receipt. So this is what I'm going to be billed at the end of the day. And then that's one. And then regarding the Azure Foundry, and then the Azure, I know we have Azure AI Studio and Azure, Azure AI Studio. I mean, what's the difference? Because why wouldn't they just improve the other one rather than have Azure Foundry? So yeah.
So I'll speak on the rate limiting bit and monetization, but I think my colleague will speak on the Azure AI and Studio, because that's where most of the work deals with. Yeah. So I think we want to kick. So you're able to do rate limiting for your APIs. I think I'll just show. Okay. Yeah. You're able to do, okay, I'll start with the monetization because that's where now you actually need to see how that rate limiting effect. So FPAM, so FPAM doesn't provide the monetization feature out of the box. So like there's no direct way where, like the use case you're mentioning. So if a certain threshold is hit, then I'm billed based on that number of requests. So you can set up rate limiting as for that for your APIs, but you'll have now to take care of how you're consuming that data. So Azure, you can extend Azure functionality through it. So it also has an API itself where you can extend its functionality, consume that data, and now implement it for monetization. But it doesn't give you the monetization aspect directly where you're able to set up those kinds of scenarios, if I'm correct. Yeah.
The developer portal.
Yeah.
More like you could look at it like WordPress, not that advanced. So can you go further and customize it further so that if I want out of the box things, I need to have my I mean if I want to have M-Pesa integration, can we have that?
Yeah. So I think you missed, I'm not sure if you're available when I was going through the developer portal. So it's totally customizable, even from, you can do it from scratch. So like I said, if the core functionality for the developer portal does not work for you, you're able now to clone it or self-host your own. So you have that privilege. So bring your own core functionalities, like you're saying, host your own. If you are, if the functionalities available work, but you want to extend some certain aspects, so there are two ways. So I'm not sure if you're, because I've not experimented that far how you're putting it. But what I've extended is you doing the custom widgets bit, where the custom widgets works now on the display level. For the actual logic behind the logic behind how the developer portal actually works and how you can do those case scenarios in the backend. I've not tried that far to see if custom widgets work, but I know if the core functionalities entirely don't suit what you're trying to implement, you're able to do self-hosting and then add your own core functionalities to it.
Okay, and then before Azure Studio, something just came up. So
Okay.
let's say we need to get some metrics, something has happened. So we know we have Power Automate. So rather than coming here or my email, I just want to get those things on Teams. So do we have like triggers, like custom triggers on Power Automate?
Yeah.
So that I can get those things maybe in a channel or whatever, Teams channel. Maybe let's say we are a team.
So you're able to extend it with Power Platform. So if you're already utilizing the Power Platform, you're able to extend this and set those kinds of metrics even to Teams as well. Still, besides that, if it's specifically based on metrics, so I think the alerts feature, you're able to do notification to Teams as well directly without necessarily having to do integration with the Power Platform. But if your core functionality is on Power Platform, you're able to extend APIM to Power Platform as well for those kind of use cases.
Okay, thank you.
Yeah. So for Azure Foundry, I can take it. This Samuel is not in the house, so yeah. So the someone I'm noting is not in the house, but I think he'll help you with that, the difference between AI Studio and Azure Foundry, for that clarification. Thank you.
Okay. Sorry, just one last question.
Yeah.
For me, it's just about the, what do you call it? APIM. So we can expose AI endpoints, and also I can expose my own workloads endpoints. So in terms of best practice, do I need to have separate APIMs for AI Foundry, like AI specific functions, and another one for my normal REST APIs, or I can use the same one API instance and it can also achieve both? And if yes or no, what are some of the advantages and disadvantages?
Yeah. So I think I'm going to go to every developer's best answer. It depends. So what's your use case? So if, well, I wouldn't entirely recommend a separate instance, APIM instance for Azure AI workloads. It doesn't necessarily make sense in terms of the ROI or in terms of the costing, because APIM is quite expensive. Yeah. So you can use a single APIM, but if you want to do the separation, like teams that are entirely using Azure AI Foundry workloads, you don't want other developers to use those APIs. You can set up workspaces, set up the RBAC on which developers are able to use Azure AI Foundry APIs. Then now have a workspace entirely for your normal API workloads. So that's one best practice. But again, workspaces also only runs on premium. So it's again expensive. Then still on RBAC. So RBAC gives you the granular control even through, okay. Now it gives you reader. Okay, you're able to do reader access for APIs, but you cannot really do the granularity of what API. So if you're using a single APIM instance without the workspaces, so any developer who is able to access the APIM based on the role you've granted them, if they're able to modify APIs, then they're able to work on both all the APIs if they are if they are at the same layer of both Azure Foundry and your APIs. So again, it depends on what costing are you putting for your APIM and what feature is supported for that APIM instance you're using. Yeah. Okay. So thank you very much. That's my time.